Ladies and gentlemen, this is going to be chapter 10. We are only going to cover chapter in chapter 10. We're only going to cover 10.1 and 10.2, and we're not going to have any homework on this, and it's not going to be on the exam number 2. However, it will potentially be on the final exam, and I will send out a study guide for this material, so you'll know exactly what you need to know. Okay, so 10.1 is scatter plots and correlation. Scatter plots is a way of visualizing the data, and correlation is a way of coming up with a numerical measure, or what we sometimes will call a metric. It's a metric or a measure of how the variables react, or how they interact with each other. And then regression is a way of drawing a curve, typically a straight line, through the data points. So we'll see here in just a minute how that works. Okay, correlation and regression. Oh, excuse me. First section here, scatter plots and correlation. Okay, I'll let you read this, but it's a very simple concept. We want to see if there's a relationship between something. Okay, so like number of hours of study and the test scores. So you have these students here. You gather the information, number of hours that they study, and what kind of a grade they get on the final exam or what have you. Okay, now you can imagine there's a relationship, right? I mean, the number of hours you study compared to the grade that you received, you would expect there to be some sort of a relationship. And you can plot that information. So, like for 6 hours of study, you get a grade of 82. For 2 hours, you get a 63, and so forth. These guys right here, the ones that you can control how many hours you study. We call that an independent variable. These over here, you really don't control, right? I mean, you do the best you can, but you don't control what your score is. So that's what he explains in here, okay? So there's the independent and the dependent variables. And this is very good advice, very good information here about it's not always clear cut. It's not always for sure which one is independent and which one is dependent. Okay, so let's take a look at his example. Okay, so maybe the first one's a little bit clear, straightforward. Age and blood pressure. There seems to be typically a correlation. Older you are, the blood pressure goes up. That's the typical scenario that you would see, okay? So the age is something you cannot control. That's the independent variable. Whereas the blood pressure depends upon the age, and so we call that the dependent variable. Okay, so I'll let you read those on your own. We're going to plot this. We're going to depict this information in what is commonly referred to as a scatter plot. So here's the definition. Let you read that. It's in your book, obviously. And here's a cartoon for you, okay? Now remember the word linear, when we talk about something being linear, that just means a line is what that means. So what he's talking about here is this is a scatter plot. So this is the independent variable. That's what is commonly referred to as the x-axis. This is the dependent variable, okay, on the vertical axis. And what you do is you just plot these points. Each one of these points is a data point. So you study for you study for X hours. You study for 6 hours and you get this score, whatever that is, 70%. You come over here, you study for 10 hours, you come up here and you got a 90%. You see how that's going? These are each of these guys, each of those points is a data point. So that's a positive linear relationship. The more you study, the better your grade. Now remember, it's always the same thing. I mean, this is a typical XY coordinate system here. This is 0, X is 0, Y is 0 here. So as you go to the right on the X-axis, X is getting bigger. As you go up, Y is getting bigger. All right, so that's a positive relationship. How about a negative relationship? As X gets bigger, Y gets smaller. So I think the example the book uses is the number of absences. So if you have very few absences, here's a data point. So I'm going to just totally make this up. Let's suppose you had one absence and you come up here and here's your score. Okay. So for that particular data point, you have one absence and a score of 90. Then you come down this way. Let's say you have 10 absences and your score is 40. So as you can see, the more absences you have, the lower your grade is. Okay, so that's just kind of common sense. I think if you do the exercise or do the examples, this will become abundantly clear. This is called a curvilinear relationship. What it's trying to say is, hey, you know what? Sometimes as you get more and more this way, as x gets bigger, at first y will go up, but then it will come back down again. Okay, so in economics, this is a phenomenon known as a Laffer curve. Now, Laffer curve, that's just an example, obviously, okay? I'm just using that as an example. So in economics, a Laffer curve, Laffer, a Laffer curve is named after the economist that first published it or discussed it or whatever. And the idea is that if the x-axis, that's the independent variable, that's the thing that the dependent variable is depending on. Let's suppose this were your tax rate. Okay, so if you had zero taxes, you'd have zero money coming into the government. As you get more and more of a tax rate, as the tax rate goes up, well, you expect your tax income to go up. But that reaches a certain point. Let's go all the way over here. Let's suppose the government taxed you at 100%. Well, guess what? People would quit working, right? Or people would hide their income or they would evade taxes. So the idea is that if you tax too much, the revenues actually go down because people avoid paying taxes. So there's an example of a curve where it goes up at first and then it comes down, and that's just one example. This is no relationship. In other words, it doesn't make a bit of difference. This would be like saying, this is well, I'll let you look at the book. Okay. All right. So he explains all these things in here. Let's take a quick look. This is a scatter plot. You have all these different companies. How many cars do they have, and what is their revenue? So as you can see, these are ordered pairs. In other words, there's an x, y coordinate. Okay. So when I say an ordered pair, what I'm saying is it's an x comma y. 63 comma 70. So this is the cars in tens of thousands. So let's see here. 63 would be over here somewhere. Okay. So 63, that your x coordinate for this guy right here, you just go straight down, you project it down to the x coordinate. The x coordinate of this guy is 63 and the y coordinate is over here somewhere it's at 7 billion. Okay, so that's this data point right here. How about a different data point? How about this one looks like it's about 20 and 2.8. So that's this guy right here and right there. Okay, so that's that data point. All right, so the point is you plot these points and you look at them and you say, hey, I can kind of get a visualization of the information. Okay, so maybe if you want to get into current events, this is the number of days since the start of the pandemic. This is the number of people that have been in the hospital. Okay, so as the days go on, the longer the virus is in the community, the more hospitalizations you're going to get. So those are just correlations, okay? But it isn't necessarily causation. It's not like one thing causes the other. It's just a numerical or mathematical relationship, okay? All right, so I think these are all pretty clear. I mean, this is, a few examples here. I don't think you'll have any problem with this whatsoever, okay? So that's just plotting the points and talking about what correlation means. Okay, now, you know how math is. We always want to have some sort of a number floating around here. This is what's called the correlation coefficient. A correlation coefficient is a way to measure the strength of this linear relationship. Okay, and there's several different kinds. Here's the one that we're going to probably be using, I think, in this section. Okay, I'll let you read that yourself. Okay, you pause your video and read it, or read it from the book. Okay. And the concept is that we want to have a number, okay? We don't want to be using a vague language. We don't want to say things like, oh, there's a strong correlation, there's a weak correlation. Well, there's just kind of a medium correlation, because then nobody knows what I mean by that. It doesn't mean anything. So what you have to do to put a little scientific spin on this is you have to come up with a number. And here's the way it works. The correlation coefficient is a number. The values are between -1 and +1, okay? And the idea is that if it's a strong positive correlation, you're over here. If it's a strong negative correlation, you're over here. And if you're in the middle, well, there's no real linear relationship, okay? So here's some properties about it. It's a unitless measurement. In other words, we're not talking about feet or degrees or square yards or anything of that sort. There's no units that are associated with it. And as I mentioned before, it's between -1 and 1, okay? All right. If you switch the X and the Y, the value of R will be unchanged. You'll see some examples there in a little bit, I think. The idea is that if there's a relationship, there's a relationship. See, like here's a relationship. As Y gets bigger, X is getting bigger. As X gets bigger, Y is getting bigger. Okay, it doesn't make any difference if you switch them or don't switch them. That's just the way it's going to be. Okay, and similarly, as X gets bigger, Y gets smaller. Or you could say as Y gets smaller, X gets bigger. So those are the characteristics there. Now, the bad news is this is the formula, okay? It's way too hard for us to calculate it, okay? So we're not going to be doing this on an exam. I just wanted to have you be familiar with the concept. There is a formula. It's a little bit too hard to calculate by hand. Typically, what would be you would go to a website, you'd plug in these numbers, okay, the XY pairs. Here's the first X. You plug in 7, 12-4, 34, 14.3, 9, 14.3, etc. You'd plug all those in. The program would do the calculation, okay? But you can't exactly do it by hand, and certainly before we had computers, that's what people did. Okay, so what I did was I Googled correlation calculator. I got many, many, many hits. I recognized this website, this Math is Fun website, so I went to this one. Well, here it is right here. Here's one. Okay, correlation calculator. When two sets of data are strongly linked together, we say they have a high correlation. And they say enter your data as XY pairs to find the Pearson's correlation. That's what we're talking about right now. So as you can see, you put in the data. It's This is the X coordinate or the X data point, 14.2, comma 215. Then you put the parentheses around it. That's your first data point. 16.4, that's your X value, comma 325. Okay, all right, and boom, there it is. So you could do the exact same thing with the example we have in the book. It's a little bit tedious, but it's a lot better than using that formula, right? So they always give you an example, but then you put in your own data just by you erase this, delete this, and put in your own data. Okay, so you can use one of these programs if you want to play around with it. Okay, so we had a rounding rule, always got rounding rules. I don't get too involved with that. It is what it is. Okay, so to actually calculate this, this author always likes to have a step-by-step process. That's really good news if you're learning it for the first time. But it all boils down to is just crank it out. Here's the tables. You just plug them in. Obviously, this is why you want to use a calculator. And you can imagine this is if you have, looks like 6 data points. What if you had 10,000 data points? I mean, it would be unbelievably difficult. You couldn't possibly do it. Okay, so there's several examples. I don't recommend, this is now, always before I told you, write out the examples, write out the examples. That's not true anymore. Chapter 10, and I think we're going to do a little bit in one more chapter. I forgot the number, but I might ask you to write these out. That would be not a good use of your time. But just look at them so you have an idea of what it's all about. And then keep in mind, watching the news when you see things like this, understand what you're talking about in terms of what does it mean when people talk about something being correlated. Okay, so that's the end of recording number 1. I'm running out of time on this tape. I will resume and we'll talk about the significance of the correlation coefficient on the next recording.